Hey YouTube, what's up? Dr. T here from St. Petersburg, Florida. So in a multi-part series, we will take a look at NVIDIA's GTC Japan VOLTA and how this special next generation GPU for deep learning will revolutionize the field of artificial intelligence. You're looking at a schematic representation of the new pier that is currently being built in St. Petersburg, due to be finished later this year, early next year. It's been a long time. The old pier was kind of demolished a few years ago. There's a lot of wrangling politically about it. And there you go. There's a picture of what the new pier is going to look like.
Ladies and gentlemen, please welcome NVIDIA founder and CEO, Jensen Huang.
Ohayou gozaimasu! I love coming to Japan. Great people, great food, great culture, great ramen. I love coming to Japan. Thank you all for coming to GTC. GTC is for scientists, researchers, and developers whose work is so computationally demanding that it is impossible to achieve with normal computers. They seek out our style of computers because it gives them an enormous boost in the capacity and the performance of the work that they do. Over the last several years, as CPU performance has begun to slow, and yet the computational demand of their work continues to grow, GTC has expanded and exploded. In just the last 5 years, attendance of GTC has grown by a factor of 10x. It is now a global event. The number of developers of GPUs has grown by a factor of 15 times in just 5 years. And in fact, the developer architecture, the computing architecture we created 12 years ago called CUDA, and its SDK has been downloaded millions of times. And just this year, 2 million times. There's no question there is a computing movement in front of us. The driving force behind the GPU that made all of that happen is computer graphics, real-time computer graphics. Real-time computer graphics has two very important characteristics that comes together in a very powerful way. The first is that computer graphics is computationally unbounded. It takes an enormous amount of computational horsepower to create an image so subtle, so beautiful, that we believe it's real. It is basically recreating virtual reality. It is basically doing physics simulation. The ultimate scientific computing application, simulating physics, generating a virtual reality that is so beautiful that we believe it's real. And yet, the second characteristic about computer graphics is that it is an enormously large market. Usually, high performance applications are small markets, and low computational requirement applications have large markets. It is very, very rare that the two of them come together in this unique way. Computationally unbounded on the one hand, enormous market size on the other hand. The combination affords us enormous R&D budget to advance this computing form. In fact, today, no processor in the world can afford the level of R&D budget that we invest in any single generation. Billions of dollars could be invested into this NVIDIA GPU because the market size is enormous and because the computational demand is utterly unbounded. Computer graphics has come a long ways. And such enormous market size is what created the GPU. And that GPU is the world's most advanced parallel computing processor. And then one day in the year 2012, three things came together which ignited the modern Big Bang of AI. And those three things was created as a result of a young researcher whose name is Alex Krizhevsky at the University of Toronto, experimenting with deep neural nets running on a GPU, and he submitted his results to the ImageNet contest, the CVPR contest. And as a result, he won the Computer Vision Image Recognition Contest of 2012. The achievement is utterly unbelievable. And it's utterly unbelievable because he has no special training in computer vision. And in one single stroke, he was able to defeat decades of computer vision experts with image recognition, using computers to recognize images. The network is called AlexNet. By today's standards, it is absolutely tiny. However, in year 2012, it was the single best computer vision algorithm the world has ever seen. Now, it uses a technology called deep learning. And deep learning is something that almost everybody has heard about since. In the last 5 years, it has swept the computer industry. Deep learning has been invented decades ago, in fact. However, it has one enormous handicap. Its handicap is that it requires an enormous amount of data to train the network. And it's a large network with an enormous amount of data to train, and as a result, it needed supercomputers with weeks and weeks of computation time in order to train and develop that software. It has prohibited deep learning from becoming effective until the advance of the GPU. The GPU discovered, researchers all over the world discovered around that time, that using NVIDIA CUDA GPU could train their deep neural nets in a very short period of time. A short period of time in 2012 was about a week's time. Literally, a computer would develop software by itself, running calculations after calculations after calculations for 1 week's time. The final network was the best computer image recognition software the world had ever seen. The effectiveness of deep learning was realized. The power of deep learning is that the more data you give it, the greater the network, and the greater the computational capability, the greater the effectiveness. Now that we realize the power of deep learning, we can invest and build ever more complex networks, gather more data, and build ever faster supercomputers. That three combination, deep networks, larger networks, more data, and more compute, the combination triggered and ignited the Big Bang of modern AI. And the effectiveness continues to grow. Since then, amazing things have been achieved. We've now achieved superhuman recognition of images. Computer vision recognition has now surpassed human abilities. We can now achieve superhuman abilities in speech recognition. What goes in as spectral information of sound can be interpreted into natural language. What goes in as just an image could be recognized with objects and detected in the image. Image recognition, speech recognition, and so many other examples that I'm going to show you have now achieved superhuman levels. Really, really incredible. This software technique that I've simplified here has profound impacts on the industry, and it's the reason why we have dedicated our entire company, our full resources, to advance this computing field and build the AI computing platform for the industry. This year, our engineers, our partners all over the world have been incredibly busy. This is the year of VOLTA. VOLTA is the first GPU that was architected from the ground up to fuse numerical computational approaches with deep learning approaches. For the first time, it introduces a new type of instruction called tensor core, and as a result, was able to achieve a computational throughput for deep learning that has never been imagined before. 125 teraflops of deep learning training performance from just one chip. It's built from 12 nanometer FinFET, 21 billion transistors, HBM2 memory, 3D packaging, VOLTA, which I have one right here. VOLTA is the most complex chip the world has ever built. Over $2 billion of R&D necessary to build VOLTA. This year, VOLTA was announced, and it is now in full production. The NVIDIA VOLTA, 125 teraflops of deep learning tensor core operations per second. The VOLTA processor is also incorporated into a new type of supercomputer. This processor is incredibly complex. And to build supercomputers based on this processor is also complex. And so what we've done is we've integrated all of the complexity into a simple appliance to purchase. A DGX, as well as a DGX station. A DGX is the world's first 1 petaflops AI supercomputers. 1 petaflops inside just one box. All fully integrated with 8 NVIDIA VOLTAs, connected with NVLink, which is 10 times the bandwidth of PCI Express, all integrated with software. All you have to do is take it out of the box, plug it in, and your AI researchers could be productive instantaneously. DGX. We also put VOLTA in every single cloud. Every single cloud service provider has adopted VOLTA. Every single computer maker in the world has adopted VOLTA because they all recognize this enormous opportunity to contribute to the future of artificial intelligence. They all recognize the enormous market opportunity of artificial intelligence. Every single cloud, every single computer maker. The software of deep learning is incredibly complex. You're talking about software that is essentially running on multiple GPUs, multiple servers, and it runs for days, if not weeks at a time. It is the largest computational problem we know today. This software stack is a high-performance computing software stack, and there are so many different types of frameworks. Framework is an artificial intelligence neural network development system. There are so many different frameworks in the world. And so what we've decided to do is optimized, integrated, and performance-tuned every single framework, every single layer of software, integrated on top of our VOLTA, and we containerized it and put it in the cloud. Every one of these software stacks, incredibly complicated, performance optimized, we've containerized and we put it in a cloud registry we called the NVIDIA GPU Cloud. The NVIDIA GPU Cloud is not a cloud service. It's a cloud registry. It's a container. It's a store. It's an app store, if you will, of deep learning framework software. That cloud, NGC, each one of the containers are virtualized. And these virtualized software stacks can run on every cloud, and they can run in every server so that the NVIDIA architecture could be hybrid cloud, it could be on-prem, or it could be multi-cloud. NGC containerizes all of this complicated software and put it into a cloud registry. From training the software, this year we also announced TensorRT for inference the software. Once you're created the neural network, you can ask this neural network questions. What is this? What did I say? Where is the car? You can ask it questions. Asking the artificial intelligence network question is called inference. The computational graph that comes out of these frameworks are incredibly complex. The computational graphs are enormous. we created an optimizing compiler called TensorRT that takes the computational graph from the frameworks and compiles it for all of our products, all of our processors, VOLTA, Pascal, DGX, servers, cloud. And we introduced a brand new product just last week at NIPS. This is a GPU, the VOLTA GPU, developed for researchers. We call it the Titan V. Let me show it to you. The Titan V is the most powerful PC processor the world has ever created. Ladies and gentlemen, this is the Titan V. The Titan V. It's available online. It's available online now for $3,000, $2,999, 110 teraflops peak, nearly 10 times the performance of the highest performance GPU in the world today, called the Titan X. The Titan X was based on NVIDIA's last generation Pascal. This is based on VOLTA, and this is now available for researchers all over the world. And so now, the software container, NGC, will run on VOLTA. Go to the cloud, whatever framework you use, register for the container, downloads it, this complicated software stack, and now you're doing AI development. When you're done with that AI development, you could run TensorRT, and it will optimize the software and make it run lightning fast.
So that concludes part one. We'll put this together, get it out, and come back for part two.